As we look at area under the curve, we have a normal model. The values are z-scores. This is my mean, my mu, my x bar, whatever it is you want to call it. It's my mean. My standard deviation is 1 in each direction. So as we look at this, we're going to find the area under the curve using the calculator. Okay, calculator is our friend, so we are going to use it. So let's look at this. Excuse me. Let's say first we want to find the area under the curve between the mean and 2.2. So between the mean and a z-score of 2.2. So here's my mean. My mean is 0. And we're going to say 2.2, approximately 1/5 of the way is right there. So there's 2.2. So we're looking at this area from the mean over to 2.2, all of this area right here. We know it's going to be less than 50% because from here to 3, from here right is 50%, here right is 50%. So we're given values, mean over to 2.2. So we go to the calculator, we go second distribution. We're talking about a distribution. We want the total area, so we're going to use the second one. We want the total area, so we want the second one. The normal cumulative density function. So now we look at what is the lower edge here. To the left is always lower. My numbers are getting smaller going to the left. So 0 is my lowest number. My biggest number is 2.2. 0 is my left. 2.2 is my right. My mean is 0. And obviously my standard deviation, we're going up and down by ones. So that's my standard deviation. So there's my normal CDF of 0, 2.2, 0, and 1. And that's approximately 48.6%. So a normal model from 0 to 2.2 with values of a mean of 1 and a standard deviation of 1, a mean of 0 and a standard deviation of 1 is approximately 0.486 or 48.6%. Those are approximate. So we found this was our left, this was our right. So we found the distance between the mean and 2.2, from the mean to 2.2. And that area under the curve is about 48.6%. Still less than 50, but about 48.6%. So let's change this. Let's look at what if we want to find the area between two different numbers. And let's just, as a wild number, we want to find the area between, let's say, a negative 1.5 and let's go 1.1. Let's go 1.1. There's our margin there. We're going between negative 1.5 and 1.1. So we look, approximately here is a negative 1.5, and approximately here is 1.1. So now we're looking at this area. I know we have overlaps. It doesn't matter. You can get over it. So finding area under the curve. Hopefully you can see my shaded region there from negative 1.5 to 1.1. So back to the computer. Whoops, not y equals. Second, quit. Second distribution. Again, we're finding area under the curve between two values. So again, we're using the normal CDF. Now, what is my farthest left value of my range here? My range is from a negative 1.5 to a 1.1. So my lower number to the left, farthest to the left, is a negative 1.5. Make sure you hit negative and not minus. Sorry, I missed every bit of that. Make sure you hit negative. Make sure you hit negative, not minus, when you're putting in a negative value. So I go a negative 1.5, enter. And if you remember, my other number was 1.1. Now again, my mean is still 0. We're talking about z-scores. For z-scores, the mean is always 0. My standard deviation is 1, always with z-scores. That does not change. So we enter, 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 and there's my model. It's a normal CDF, a cumulative density function between negative 1.5, 1.1, with a mean of 0 and a standard deviation of 1. That looks like 79.8%. So my normal CDF here is going to be a negative 1.5 to 1.1, my mean and standard deviation, and that's going to be approximately, let's go ahead and call it just 0.798, also known as 79.8%, or just about. Okay, so finding the area between z-scores under the normal model, our mean is 0, standard deviations are 1. We simply go to normal CDF, oops, there's a glare, normal CDF, and take care of each part. I hope that helps.